We're going to review basic measurements and basic unit conversions here to start. These are things that will kind of lead us into, different stoichiometry principles and conversion principles. These are things we should be good with from Chem 1, but it's been a while since we've done measurement and unit conversion. So we've got different base units that we need to use for all of our different types of measurements. So the base unit for length is meter. It's abbreviated with just an M. Okay, these ones should be ones that are the same, like we've seen these before. Base unit for mass is kilogram, which is kg. Okay, why do we think it's kilogram instead of just gram? What'd you say? You could have been right. Okay. Kilogram is a more accessible type number. So if we would measure things in grams, we would have a lot of measurements that are in the thousands, right? And so rather than deal with measurements that are thousands of grams, kilograms just gives our numbers a more accessible feel. Gram is still like where we find ourselves at the base of like our metric prefixes chart, right? Gram is still like the middleman, but kilogram is what we consider the base unit here. So we use it most often for mass. Time is measured in seconds and temperature is measured in Kelvin. We talked about Kelvin last year when we did gas laws, right? That was where we saw Kelvin really probably first. In Chem 2, we're going to dive into a whole bunch of stuff with temperature and heat and how that affects the energy of a solution and things like that. So Kelvin is something that we'll need to get used to. Anyone remember how to convert to or from Kelvin? What that number is?
Is it like
273. 273, right? We would take Celsius and add. Yeah.
Is Kelvin named after like the scientist who discovered it?
Mm-hmm. Yeah, I don't know if you can call it discovered temperature, but yeah, he probably did something with the scale. But yeah, that's his name. So yeah. If I'm being honest, I don't know which one came first. Did Celsius come first or Kelvin come first? I don't know. Whatever. We could look it up. Amount of substance is measured in moles, right? Not grams, moles. So why do we measure amount of substance in moles rather than grams?
Because it's the amount of atoms.
Yeah, good. Moles tells us a true quantity of atoms, right? And grams tells us how much those things weigh, right? There's a difference there because 2 oxygen atoms weigh a much different amount than 2 hydrogen atoms, yet they make up the same quantity of substance, right? So we've got to make sure we're talking about things like apples to apples, not apples to oranges. So. All right, the other ones I don't think I even gave you. I don't even think I listed all 7 there. 1, 2, 3, 4, 5. Okay, the other 2 are amps and candelas. We don't get to those. Okay. Other units I want you to be aware of, some volume conversions. Okay. These 2 things are the same. A milliliter and you know what this is called right here?
Cubed centimeter. Centimeter cube.
A cubic centimeter, or sometimes abbreviated cc for cubic centimeter. Remember how we talked about cc's? What community uses the term cc's? Right, medical communities use cc's because if we say I need 50 milliliters of something, right, it just takes too long. So cc's is the typical term for medicine.
Whoa.
Celsius to Kelvin is add 273, and Kelvin to Celsius is subtract 273. Okay, so when we're at 0 degrees Celsius, that means we've got a temperature of 273 Kelvin. And do we report Kelvin with that degrees? No, Kelvin just says Kelvin, right? No degrees, Kelvin, just Kelvin. Okay. What does what happens when we reach this value right here?
Absolute 0.
Right, when we get to negative 273 Kelvin, we reach something called absolute 0. And what happens at absolute 0?
I don't know.
Things stop moving, right? There's an absence of movement. There's not enough energy in particles for them to move anymore, so like things cease to exist.
What if that got
And what?
on
We would be donezo. Probably long before that.
Rip.
And what maybe when they fall into a ball? Some balls.
I've given you conversion factors between US and metric system. I changed the chart for you guys a little bit so that the bigger unit always gets the 1. This is one that I sometimes memorize the other way around. I usually say like a foot is equal to 0.305 meters. You can use whatever version is best for you. These are things that you'll need to memorize. These aren't things that I'll give you anymore in Chem 1. I gave them to you. Here you'll need them probably memorized. Although this is not something we see a lot. Our conversions most include like moles to grams, stuff like that. So, and temperature conversions. Okay, but these are your conversion factors from US to metric. So you can put these down if you want. Let's get back to our conversion. So we're going to start with some easy ones here. It says how many seconds are in a leap year? So what does that mean we need to start with?
How many days are in a week?
We start with days, right? Because we weren't even given a number to start. 366
Times.
days. Right, we always start our T-chart with what we know, and I know there's 366 days in a leap year. So I'm going to go days to what? Hours. So I say one day is 24 hours. Then I can go from hours to minutes. You could go hours right to seconds if you wanted, that's fine. Or you can go minutes to seconds, so 60 seconds in 1 minute. Are we looking for a big number here or a small number here? Should be a huge, huge number.
I only remember that because of oh my god. And then yeah.
Me?
No, different.
Oh,
It
yeah.
was like the
They sing it on The Office, too. Or they change it for, Michael. All right, is this what we had for seconds?
Yeah.
31,622,400 seconds. Okay, but that's what should we should be. That's what we should be expecting, right? Is a really big number. Okay, this conversion you should have written in your notes. We always start with what we know. 4.3 pounds. How many grams are in a pound? Or how many grams are in what's on your chart?
It's just grams to ounce.
Okay, so it goes grams to ounce. So let's go pounds to ounces then.
6 ounces.
Yeah, so in 1 pound, 1 pound is 16 ounces. That's an American conversion. 16 ounces. And then it tells you that 1 ounce is how many? 28 grams. See, I would have guessed that the opposite because I feel like ounces are so small that I would have thought there's 28 ounces in a gram, but I didn't know ounces were that big, 28 grams is like kind of a lot, so I don't.
Yeah.
That's interesting.
Like 20 physically.
Otherwise, if it was
All right, how many grams did we end up with?
1,900.
I got 1,930. No?
about the same thing.
What'd you get, Hannah?
I got 1,900.
Oh, I did 4.31. I didn't recognize that was part of the pounds. Okay, 4.3 times 16 times 28. Okay, 1926.4 grams. Okay, good. Do the next two on your own. Inches to meters and centimeters to feet.